Howdy folks, Mr. Reed here, and welcome to One More Question. What we're going to be doing today is multiplying or expanding out a pair of questions, both of which are binomial times binomial, and we're going to put it up to a medium level this time. So last time I had just positive values everywhere and no coefficients, so we're going to introduce a little bit of extra zip to it. Still going to be hopefully pretty straightforward when we get into it, but it doesn't go as well with an area model, as we'll see in just a moment. So if what you're looking for is multiplying binomials, let's get to it. All right, so I got a couple questions up above. The first one is fairly straightforward, except for there's one little wrinkle to it, and that wrinkle is that the second binomial has a negative sign in it. Now, it's going to work basically the same way as with integer multiplication. So positive times a positive is a positive. Negative times a negative is a positive. And any mix of the two signs, so positive, negative positive, is going to give you a negative value. So we're going to see that kind of coming into play here. However, when we go to do, as I kind of said before, an area model, if I were to make a rectangle and say, oh, well, this part of the rectangle has x as its size, and this part has x as its size, and I were to kind of draw that along here and here to slice it up. I said this has a size of 1, this has a size of -3, and that's kind of weird, because that actually means it's eating into the area that's already there, and that is not really easy to show in this particular type of diagram. So while it kind of falls apart from an area point of view, it's still going to follow the exact same pattern as what we developed last time. So we're going to get x times x, and that's going to be equal to x squared. We're going to get x times -3 in the top right spot, and that's going to be -3x. So you get a negative times a positive, and the overall result is a negative. We're going to get 1 times x. Those are both positives. That's going to give us x. And we're going to have -3 times 1, which is going to give us -3 as our result there. We're going to, as we did last time, add together all of the individual pieces that we just created. When we do that, we have 2 in the middle that are like terms, so they're the same type of flavor, or the same, we can put them together because they're apples and apples if you wish. So I only have one term that's x squared, and so there's only one of those, and it's the x squared. I have -3 and another +1, and they're being added together. It's -3 plus x, or sorry, -3x plus x. That will give us -2x. So just like normal integer addition there. Now we have just the -3, a number all by itself at the end, so -3 it is. So that would be how I would do that first one if I was kind of showing you this kind of box method. The box method is a little bit of a departure from how we used it last time, though, because it doesn't correspond with an area model very well. So because of that, we basically get this idea that it's just a nice graphic organizer. So if you like arranging the letters on the outside of some rectangle like this, or you could even make it square if you're okay with the fact that the lengths don't really match up, that's totally fine. And then you can just fill in the blank in the 4 quadrants that are there and get, in this case, x squared, -3x, x, and -3. Totally fine to arrange your stuff that way. However, if I wanted to do that same question without drawing anything, so we're going to use this idea of distributive property, which is going to say that each of the things in the first bracket, terms, shouldn't say things, is going to multiply with each of the terms in the second bracket. So that means x is going to multiply onto x is also going to be multiplying onto -3, 1 is going to be multiplying onto x, and 1 is also going to be multiplying onto -3. We'll take the result of all 4 of those multiplications. X times x is x squared. Next up, we are going to have x times -3 is -3x, plus 1 times x is plus x, and 1 times -3 is -3. The order in which you do those multiplications has no bearing on what's going to happen afterwards, because the addition at the end can occur in any order, so it doesn't really matter whether the -3x comes before the positive x or vice versa. It's still going to simplify the same way and give us x squared minus 2x minus 3, just like it did last time. But you can look at it from no real kind of picture to go along with it, just the algebraic approach. All right, so that is the first one that's above me. The second one is much the same, except for it's got a little more pizzazz to it. But if we really are set on interpreting things as every term in the first bracket multiplies every term in the second bracket, then it really doesn't matter the order of those terms, the sign of those terms, whether they have an x in it or not. As long as we're comfortable with multiplying monomials, which is what we call single terms, then this multiplying binomials is just a few of those in a row. So what we'll do here is say the two terms in the first bracket are each going to multiply the two terms in the second bracket. That would give me 4 times negative x and 4 times negative 3. Also negative 5x times negative x and negative 5x times negative 3. So let's go ahead and do that. The 4 times negative x is negative 4x. The 4 times negative 3 is negative 12. The negative 5x times negative x is plus 5. And x times x gives us x squared. And then last we have negative 5x times negative 3, which is plus or positive 15x. So I just kind of put them all together already, right next to each other. Next up, we're going to simplify if we can. I like to write things in descending order. What that means is I take the thing with the most or the highest number of x's in it. And by highest number of x's, I mean the highest order, which in this case is going to be x squareds first, then just x, and then things without x in it at all. So in this particular case, I'm going to say 5x squared, and that's my x squared term. And then I have two things with just x in it. I have a negative 4 and I have a plus 15. If I put negative 4 and plus 15 together, I'm going to get plus 11x. And then to finish that off, I have still my minus 12 kicking around at the end. So I would get my final answer there of 5x squared plus 11x minus 12. And that could be done, again, organizing it with the rectangle method. It's going to give us the same answer in the end. So if that's the way you want to do it, try it out. See if you get this, and that's good. As I was trying to say, really the ordering doesn't matter. What is really important is that you get into a groove of every term in the first bracket multiplies every term in the second bracket. That's how we do it with binomials. Luckily, if you keep following along, we're going to do some stuff with even trinomials and kind of a mixture of binomial and trinomial. And those are going to be done using that exact same method. So every term in the first bracket multiplies every term in the second bracket. So if you get comfortable with that, it's going to take you through a bit more stuff coming up. All right, folks, I found that helpful. Like and subscribe. And as always, take care.